Hi, my name is Dominique Lopiccolo, and I will be sharing with you all about the research I conducted with Dr. Charles Chang at Boston University. In our study, we investigated several factors during numerosity processing. Numerosities, or object sets, provide us with some of the most basic structures for understanding numerical magnitude. Numerical magnitude has also been seen to be linked to space. The Snark effect is something which shows this link. More specifically, the Snark effect is characterized by overall left-hand biases to small numerical magnitudes, but overall right-hand biases to large numerical magnitudes. This behavioral bias has been used to propose the existence of an internal mental number line which maps increasing numerical magnitude from left to right. Script direction effects are something which complicate this view. In Dehane and colleagues' seminal work in 1993, they recruited right-to-left Farsi readers who demonstrated an overall weakened Snark effect and in some cases a reverse right-to-left Snark effect. Task instructions are another factor which seem to influence these biases. In Patra and Shaki 2016, depending on the context of their task, participants either showed a strong left-to-right Snark effect or a weakened and even reverse right-to-left Snark effect. Different culture effects, such as script knowledge and visual experience, seem to be conflated in the literature. For example, in Dehane and colleagues' similar work, they recruited their right-to-left script readers from Parisian medical schools, which begs the question of whether or not they also had left-to-right script knowledge. The objective of our study then was to investigate the roles of quantity, task instructions, script direction, and visual experience by incorporating specific directional and literate groups. For this reason, we recruited Arabic monoliterates and Arabic English biliterates living in a predominantly right-to-left reading society, namely Jordan, and English monoliterates and Arabic English biliterates in the United States, a predominantly left-to-right reading society. All groups were tasked to complete a pairwise numerosity comparison task with two conditions. The first being to find the smaller of two numerosities, and the second to find the larger of the two numerosities. The order of conditions were counterbalanced across participants, and a later analysis showed there was no significant effect of order of instructions. After the comparison task, participants completed a language background and proficiency questionnaire, as well as the Edinburgh-Candace survey. Our numerosity stimuli were generated using a MATLAB script specifically designed for pairwise comparison tasks. The numerosity stimuli were further subdivided into small, large, and cross-range pair sizes after similar previous task designs. Our results showed that the English monoliterates and Arabic English biliterates living in the United States showed a significant task-dependent Snark effect. That is, they showed a left-to-right Snark effect when finding the smaller numerosity, but a right-to-left Snark effect when finding the large numerosity. Our Jordan-based groups did not show an effect of condition or pair size, therefore they showed no effect. And finally, the comparison between the biliterate groups living in opposite monodirectional cultures did not show a significant effect of environment. Instead, we also conducted a more nuanced comparison where we looked at preferred language for counting. And what we found was pretty interesting. The biliterates who reported having no preference for a language for counting actually showed more robust left to right Snark effects compared to those biliterates who reported English as their preferred language for counting. Since we did not find any right to left Snark effects in our monoliterate Arabic groups, this provides support for a more recent innate left-right code theory, which has also been supported in studies on human infants and non-human animals. The task dependency effect we found has replicated previous findings and also supports the existence of an ordinal task-based code during numerosity processing. While environment did not have an overall effect, we did find a preferred language for counting effect, which warrants further investigation in the future. Taken together, there seem to be several spatial numerical mapping codes involved during numerosity processing. We explain these outcomes via our multiple competing codes theory, where we state that factors such as task instructions and demographics pose specific constraints on which of these multiple codes are activated or suppressed. In the future, we hope to increase the range of numerosities tested to avoid such things as a supertizing range effect, as well as adding neuroimaging and eye tracking components, which could provide a more sensitive measure for differentiating across the cultural groups. Finally, further investigation in the bidirectional counting preferences would be something interesting and worthy of further research. Thank you again for your time, and I look forward to your questions.